Okay, guys. So if you're watching this, you're trying to get a better understanding of how to convert moles to representative particles and representative particles to moles. So I'm going to walk you through this one piece by piece, step by step, math by math. Okay. So this whole problem or this whole worksheet is about Avogadro's number. And Avogadro's number is 1 mole is equal to 6.02 times 10 to the 23rd representative particles. And a representative particle can be an atom, an ion, a molecule, or a formula unit. Now, to be clear, an atom is anything that you can find on the periodic table. Hydrogen, oxygen, uranium, neon, all those various elements, all 118. An ion is any of those with a charge, a positive charge or a negative charge. A molecule is multiple atoms, but are non-metals, all non-metals. A formula unit is between a metal and a non-metal. And you obviously have your periodic tables that are color coordinated, and you can determine which ones are metals versus non-metals. So you have to have these measurements with your numbers. You can't just say a number. You have to follow up with X number of atoms or X number of ions or X number of molecules or X number of formula units, okay? So you'll get hopefully a sense of what I'm doing and which ones I'm using as I go through this worksheet. So you got a pretty simple one of just converting. This whole problem here, number one, is about conversion. So 1 dozen is equal to 12. A gross is equal to 144. That's 12 by 12. A pair is 2. A ream of paper, we talked about in class, that's 500. A score, I never talked about, but it is 20. But then the important one that they're discussing here is a mole, 6.02 times 10 to the 23rd. And it could be atoms, it could be ions, it could be molecules, it could be formula units. And that goes to number 2. List the 4 types of representative particles that are referred to in your textbook. Atoms, ions, molecules, and formula units. Okay. Now I have my calculator on standby. I know you guys can't see it, but I assure you I have it, and you should have one with you too. Okay, so let's begin. Number 3, determine the number of representative particles in each of the following. Show the factor label method. That's basically what we've been doing. It's dimensional analysis. So we start off with 0.250 moles of silver. Your conversion is going to be 1 mole is equal to 6.02 times 10 to the 23rd blanks. Now, we're dealing with silver here. Silver is an atom, so your representative particle is an atom. I'm going to put 6.02 times 10 to the 23rd atoms of silver on top and 1 mole of silver on the bottom. Silver's atomic symbol is Ag. That's according to the periodic table. And the reason I put moles on the bottom, and this part I mentioned in class, the math in this class is easy. I have no doubt about you guys being able to multiply and divide. It's knowing where to put what, because we all know there's a major difference between 2 times 2 versus 2 divided by 2. I want moles to cancel out. In order for that to happen, I need to have the same term or the like term on the bottom here. That's how I know every time. So moles cancels out. So I'm going to put in my calculator 2.50 times 6.02. And I have a raw answer of 1.505 times 10 to the 23rd atoms of silver. Now there's one teeny tiny catch. Your original number has 3 sig figs, 0.250. So we need our answer to have 3 sig figs. Right now it has 4. So we're going to keep the 1. We're going to keep the 5. But then that 0 is going to round up to a 1 because that's a 5, and you just erase the 5. So your answer is going to be 1.51. times 10 to the 23rd atoms of silver. Okay, let's continue. 8.56 times 10 to the negative third moles of sodium chloride. I want to put 1 mole of sodium chloride on the bottom because I want them to cancel out, and I'm going to put Avogadro's number on top. Now, sodium chloride is a metal and a non-metal, so I'm going to be doing formula units of NaCl. And I just wrote them on top of each other to save some space. 1 mole cancels out with moles. And so now 8.56 times 6.02. The raw answer is 51.5 times 10 to the 23rd formula units of sodium chloride. However, when you're doing scientific notation, you must have your answer between 1 and 10. Well, that's 51. So you need to shift the decimal 1 to the left, and that's going to cause your exponent to go from 23 to 24. So let me just kind of clean that up. This 5.15 times 10 to the 24th formula units of sodium chloride. Let's move on. 35.4 moles of carbon dioxide. Okay, 1 mole goes on the bottom because I need moles to cancel out. 6.02 times 10 to the 23rd. Now, carbon dioxide is a nonmetal and a nonmetal, so it's going to be molecules of CO2. Moles cancels out. You're going to multiply 35.4 times 6.02. My raw answer is 213 times 10 to the 23rd molecules of carbon dioxide. However, that's not proper scientific notation. The decimal is right there. I need to have a number between 1 and 10, so I'm going to shift the decimal 1, 2 to the left. 2.13 times 10 to the 25th, because I moved the decimal 2 places to the left, the value of the exponent goes up by 2, or the scientific notation. Okay? I would ask if there's any questions, but obviously we're not together if you're watching this. Continuing on. 0.425 moles of nitrogen. Okay? 1 mole of nitrogen goes on the bottom. Avogadro's number goes on top. And we have nitrogen that's N2. Those are 2 nonmetals. So it's going to be molecules. Molecules of N2. Nitrogen gas. Moles cancels out. 0.425 times 6.02. That's going to equal 2.56 times 10 to the 23rd molecules of nitrogen gas. Okay. Now, to double check, to show you guys why my answers are in 3, each one of these, A, B, C, and D, have known values with just 3 significant figures. And so I have to have my answer with also 3 significant figures. You don't have to consider significant figures when you're actually doing the conversion. It's not the conversion that you need to worry about the sig figs for, it's the known values. Let's move on to page 2. Looks like we have about 8 to do over here, okay? So let's just knock them out. Determine the number of moles in each of the following. Show the factor label method. Again, that's basically just dimensional analysis. All right. I have 3.25 times 10 to the 20 atoms of lead. Now, atoms is a representative particle, so I need to put Avogadro's number on the bottom. And I'm going to have atoms of lead. And that's going to be under 1 mole of lead. Whoops. Atoms of lead cancels out. You're going to do division here. So 3.25 divided by 6.02. My raw answer is 0.540 times 10. Now, this is way back in unit 1. When you are using scientific notation for addition, or excuse me, for multiplication, you add the exponents. But when you're doing division, you subtract them. So we have 20. Hold on. We have 20 and we have 23. So 20 minus 23 is -3 moles of lead. But obviously that's not proper scientific notation, so I need to move the decimal 1 to the right. So the number is going to become reduced. So it's going to be 10 to the -4. So your new value is 5.40 times 10 to the -4 moles of lead. Next, 4.96 times 10 to the 24th molecules of glucose. Glucose is sugar. So because we know it gave us molecules, molecules is going to be your formula unit, or excuse me, your representative particle for this problem. So you're going to put Avogadro's number on the bottom. And you're going to put 1 mole of glucose on top. You cancel out moles of glucose, or excuse me, molecules of glucose. 1 second. Hey, sorry about that. I just had to go answer the door real quick. Let's pick up where we left off. All right. So this is going to be a division problem. 4.96 divided by 6.02. And my raw answer is going to be 0.824. 24 minus 23 is going to be times 10 to the, 10 to the first moles of glucose. However, you got to shift that decimal 1 to the right to put it in proper scientific notation. That means the 1 will become a 0. And when the 1 is a 0, it's basically standard notation. So the answer is going to be 8.24 moles of glucose. Again, whenever you have this, that's basically standard notation. The 0 means that the decimal doesn't move. It's where it should be. And so you don't need to write 10 to the 0. You could just write 8.24 moles of glucose. Okay, continuing on. 1.56 times 10 to the 23rd formula units of sodium hydroxide. That's going to be a formula unit. That's a compound. Okay, so I'm going to put Avogadro's number on the bottom. Sodium hydroxide. And then 1 mole of sodium hydroxide is on top. Formula units cancels out. 1.56 divided by 6.02. My raw answer is 0.259 moles. Oh, excuse me, I messed up. 2.59. Yeah, 2.59 times 10 to the 0, which is basically standard notation, as I just said earlier, moles of sodium hydroxide. However, the decimal is not in the right spot. You need to shift it 1 to the right. So it's going to be 2.59 times 10 to the -1st, because the number had to go down by 1. Whenever you move the decimal to the right, the value of the exponent decreases. Whenever you move the decimal to the left, the value of the decimal or the exponent increases. Okay, last one for this set of problems. Number 4, D, 1.25 times 10 to the 25th copper 2 ions. So that's your representative particle. 6.02 times 10 to the 23rd copper 2 ions is equal to 1 mole of copper 2. Cancel those out. So I'm going to put in my calculator 1.25 divided by 6.02 equals 0.208. Again, this is my raw score. We'll adjust in a moment. 25 minus 23 will be times 10 to the second copper 2 ions. You should know that that is not proper scientific notation. We need to shift the decimal 1 to the right. So that's going to be 2.08 times 10 to the first copper 2 ions. All my answers have 3 sig figs, just like the number of sig figs in the known values. Okay, let's continue. 4 more. Make the following conversion, show the factor label method. Final time. That's essentially dimensional analysis, which is what we're doing. 1.51 times 10 to the 15 atoms of silicone to moles of silicone. Okay. So 1.51 moles of silicone. Oh, 1.51 times 10 to the 15th atoms of silicone. We're going to put Avogadro's number on the bottom. We'll put 1 mole of silicone on top. Atoms of silicone cancels out. This is a division problem. 1.51 divided by 6.02. My raw answer is 0.251. 15 minus 23 is going to be times 10 to the negative 8 moles of silicone. However, we have to shift the decimal 1 to the right. So it's going to be 2.51 times 10 to the negative 9th moles of silicone. There's your answer for that. Let's continue. 4.25 times 10 to the negative 2nd moles of nitrogen dioxide to molecules of nitrogen dioxide. So you're going from moles to molecules. Okay. One mole goes on the bottom because you want moles to cancel out. And Avogadro's number goes on the bottom. We're doing molecules today, or on this problem. Moles cancels out. This is a multiplication problem. 4.25 times 6.02. My raw answer is 25.6 times 10 to the, let's see, you have to add these. So negative 2 plus 23 is 21 molecules of NO2. That is obviously not proper scientific notation. We need to shift the decimal 1 to the left. So it's going to be 0.56, 2.56. The number is going to go from 21 to 22. C, 8.95 times 10 to the 25th molecules of carbon tetrachloride, 2 moles of carbon tetrachloride. Okay, so let's set it up. 8.95 times 10 to the 25th molecules of carbon tetrachloride. You need to put Avogadro's number on the bottom. One mole goes on top. Molecules of carbon tetrachloride cancel out. This is a division problem. 8.95 divided by 6.02 is 1.49. That is in proper scientific notation, as is. 25 minus 23 is going to be times 10 to the negative, or 10 to the second, excuse me, moles of carbon tetrachloride. And there's no further adjustment because we were fortunate in that it was already in proper scientific notation. The number was between 1 and 10. Okay, finally, last one. 5.9 moles of calcium to atoms of calcium. We want to put moles on the bottom so it cancels out, and Avogadro's number on top. And then this is atoms. Moles cancels out. This is a multiplication problem. 5.9 times 6.02. My raw answer is 35.5 times 10 to the 23rd atoms of calcium. That's obviously not proper scientific notation. The decimal needs to shift 1 to the left. It's going to be 3.55 times 10 to the 24th atoms of calcium. And that's it. If there are any questions that you still have regarding this worksheet after you've watched this video, you know how to contact me and we can work it out. All right, that is all.